Okay, so now we'll tackle problem 2. And this is a continuation of our checkerboard problem. So let's take a look at where we're starting now. So it says in checkers, players take turns moving their pieces. Starting with your solution to problem 1, extend it so that given a board size n, the positions of the black and white checkers, a sequence of valid moves, it prints out the resulting checkerboard. Okay, so what that means is extended means that we're going to start with our initial solution and move forward. So we're given a board size n, positions of the black and white checkers, which we're probably getting from our work in problem 1. Then we're going to get a sequence of valid moves. It's going to print out the resulting checkerboard. So as far as I can tell, I've already done that. And I've done all of this. So the big piece that we're going to get is a sequence of valid moves. So the pieces will position themselves and then we're going to move things around. That's my inclination. Okay, so I'm not going to copy my solution yet. I'm going to read and see what I need. So first of all, we're getting the same input as problem 1, followed by some new stuff. So that's the part that I actually care about, everything in here. So we're going to get an integer m, denoting the number of moves, followed by 4 m integers. Okay, and they're going to be of the following form: R1, C1, R2, C2. So for every number of moves, I'm going to get 4 integers, which just gives us the 4m, and it's going to denote the row and the column of the starting position, and then the row 2, C2 of the final position. So let's see what the processing says then. It says you may assume that every move is valid. That's great. I don't have to check whether or not I have something to move. And then the final board configuration is what is to be printed. Okay, so we're going to move it. And then at the end, I'm going to have the same output as problem 1. So a lot of this is the same. So if I look at what's different, this was the same, this up here was all the same as problem 1, and then I've got this new line of input, and so I'm just going to just put a little line here so I know that's all the same. And then this looks something like, so that's our m, the number of moves, followed by R1, C1, R2, C2, m times. So I'm going to get that m times. So that's the first move, the second move, all the way to the last move. So in this case, we have that 3 times. So I've got, and I can put space in there, we can see I've got the first move, the second move, and third move, because m was equal to 3. So we're going to move some things around. So we'll start with our original piece and we'll see if we get what we expected. Okay, so I know I have a new class file, and I also remember I'm going to need to import the Java utilities library. I'm going to go ahead and just copy that in. And over here, I'm going to copy my main class, everything. And then I'll deal with additions, but there's no reason ever to have to oops, got a lot of space at the end there. I'll get rid of that. Not sure how I ended up with all that. There we go. Okay, so this is where we started, and now the only thing I need to do for problem 2 is to deal with this line. Okay, so I've set up my board, and now I'm going to move some pieces. And so that's after if I look at my old work, I've created I read in the size of the board, I created the board, I've populated an empty board, I read in the number of black pieces, that's all the same, I read in the number of white pieces, that's all the same, and I'm going to leave my output the same. So all I have to deal with is the moves, and we remember it's going to be of the form, and we'll just copy and paste it. It's going to look like this. We were told that it's going to be of the form m, read in the number of moves, and then we're going to move things. So, okay, so what that means is I'm going to have to read in into M, oops. I'm going to read in that next int. I know that my scanner is set up and that's called in. And then I'm going to go from int I equals 0 to I less than m, I plus plus. So I want to loop through each of these details for moves. There's four. There's one for tuple for every move. And so what that's going to give me is I have a row 1, and I got to read that in for each of these. I have a column 1, read that in as well. I have a row 2 that I have to read in that next int. And I have a column 2. And when it says that each of these is valid, it means there's nothing that I'm going, so if I look in that position, like on the board, if it's asking me to move something from here, there's something there for me to move. And if it's asking me to move to here, it means I'm not going to put my checker on a different checker space, or it's a valid checker move, like whites are moving in the right direction, blacks are moving in the right direction, all is well. Okay, so I don't need to check really anything. All I need to do is move the piece. So I'm going to move from R1, C1 to R2, C2. And that kind of involves two pieces, right? First, I need to find out what kind of piece it is and move it to R2, C2, but then I have to make that R1, C1 empty. So the first thing I'm going to do is say board in this new location, R2, C2. I'm going to set that equal to whatever was held in R1, C1. It's as simple as that, C1. And then the second thing I'm going to do is set board R1, C1 after that. So once I've moved the piece, I kind of have two copies of that one piece, right? I'm going to say, oh, I moved it, so that position's now empty. And that's it. I don't have to change anything else about the output. I'm done. I think that's it for problem 2 as far as I read. So let's check it out. If I go back up here, so I'm going to just delete that so that I can quickly copy, not that these spaces matter, but so that it looks just like what you're getting as input. You'll see that the white space would be ignored. I'm going to copy this input, and just so that I can run it with the exact input that we expected. In fact, I want to stay up here so I can see that what I get as output is correct. There we go. And we do a quick check, scan it, 0 star, blank 0. Oh, something's fun. What did I not do? Oh, there's something wrong. So let's take a look. I mean, it's in one of these lines, and I can see it already, which is I just typed incorrectly. So what I knew was that we weren't covering, I wasn't deleting the piece after I moved it, because I have more white pieces than I started with. So clearly I'm doing something wrong. So I knew I was looking for this line here, and in fact, that's the mistake I made. So now if we run it, hopefully this time, let's see, our output matches. Okay, and that's it for problem 2. So it's okay if we make mistakes along the way, because we can fix them. That's part of the fun of programming. So I guess I'll see you at problem 3.